Permutation. Permutation means it is an arrangement. It is an arrangement of various cases are there. First we will discuss n dissimilar things. Taken or at a time. Okay. N dissimilar things taken or at a time. So that can be arranged in two ways. Actually, two types of permutation. One is linear permutation. Another one is circular permutation. Okay. One small difference. For example, we have A, B, C, D. Likewise, four things are there. We are taking 3 and arranging it. How we are arranging? What are all the possibilities we can arrange? Either A, B, C, B, C, D, D, C, A, C, A, B. Likewise, it will go. Okay. If you are arranging this in a line, it is called as linear permutation. If you are arranging that in a line, it is called as linear permutation. If we are arranging that in a circle, here A, here B, here C, then it is called as circular permutation. Okay. Also, in the circular permutation, both direction is allowed. Okay. Suppose, if any direction is specified, clockwise or counterclockwise, any direction is specified, this permutation will be reduced into half. Okay. That is all the initial notes. Taken, there are n dissimilar things are there. Among the n dissimilar things, we are arranging only r things at a time. Okay. Then, the permutation means it's an arrangement. If you are arranging those elements in a line, means it is called as linear permutation. If you are arranging those things in a circle, means it is called circular permutation. In a circle, direction is not specified, means we will have twice, okay, twice of the arrangement, twice number of the arrangement. In a circle, if suppose direction is specified, among the total number by 2, only half of the arrangements is allowed. Okay, clear? Underline that word. It is an arrangement. In your book, underline that it is an arrangement. We'll come back to that point later. Okay. Also, there is one formula. I told you, no. N dissimilar things. Oh, yeah, erase that. Taken or at a time. Then the permutation is NPR. Okay. What is formula for NPR? It is n factorial by n minus r factorial. Okay. What is this factorial notation? When we say n factorial means n into n minus 1 into n minus 2 into up to 1. Also, you should note that 0 factorial is equal to 1. 1 factorial also equal to 1, but 0 not equal to 1. Okay. This clarity you should get. So, these are all the things we will use. Shall we move to questions right now? Yeah, also, there is one another thing. That is, this n is right. This n should always greater or equal to, not n, r. R should always be less than or equal to n. That can be less than n or equal to n. Because as per the definition, the actual definition, I told you that n dissimilar things taken or at a time. The actual definition is, there are finite number of things we are taking some or finite number of things from that and arranging it. That definition we will follow. So here, since it is n dissimilar things taken r at a time, from that n alone we are taking, so that r should be less than or equal to n. For instance, a b c d is there. I wrote previously a b c d. I told you that taken r at a time means taken 3 at a time. Likewise, you may think taken 1 at a time, taken 2 at a time, taken 4 at a time, taken 5 at a time is possible? No, because here n is equal to 4, here r is equal to 5, not possible. That is greater. Okay, this r should be less than or equal to 4. Clear? Any doubts on this? Then we'll move to the questions. So we'll finish all the theory questions first. The third question is the number of permutation of 5 dissimilar things taken 4 at a time. Then how many permutations can be formed? 5 dissimilar things taken 4 at a time. It is NP4. Okay. The formula is 5 factorial (1 factorial 5 factorial) 120. Okay, good. See, 5 factorial by 5 minus 4 whole factorial. 5 factorial is 5 into 4 into 3 into 2 into 1 divided by 5 minus 4 is 1 factorial. When we multiply all this, 5 2s are 10, 4 3s are 12, then 120. Okay. Next question. If there are 25 railway stations on a railway line, how many single second class ticket must be printed? How many single second class ticket must be printed so that the passenger so as to enable a passenger travel from one station to another station? In a railway line, totally how many stations are there? 25. So from one station to another station he should travel. Likewise, how many tickets has to be printed? So among 25, how many stations connected by one ticket? It's kind of arranging two things out of 25. Is it or not? So the required answer is 25 T2. That's all. From one station to another station. Each station is connected. Okay. Totally there are 25 stations. On the 25 stations, we have to enable the passenger to travel one station to another station. Likewise, how many second class tickets we can print? So out of this 25, if you take one ticket means that ticket should connect two stations, either 1 2 or 3 4 or else 2 4, any two, or else 2 and 24. So that like how many tickets we can print is the question. So minimum how many things we should choose for a ticket? 2 out of 25. Okay, so the required number of tickets is 25 P2. So 25 factorial divided by 23 factorial. These two can be simplified. Then we have 25 into 24. You know this cancellation, right? How I am cancelling this? This can be written as 25 into 24 into 23 into 22 into 21 up to 1. This can be written as 23 into 22 into up to 1. So this the denominator 23 up to 1, the numerator 23 up to 1 can be cancelled. Okay. So 25 into 24, how much? 600 something. Is that 600 or something? 5 4s are 20, 2 4 2s are 8, 10, 18, 20, 2, 4, 6. 600. Something is not there. Okay. Next question. In a class, there are 30 students. On the New Year day, every student posts a greeting card to all his or her classmates. Why his or her, either boy or girl, they will post greeting cards to everyone. Okay. Find the total number of greeting cards posted by them. $30 children, man. First person will post how many postcards? 29. Second person will post how many postcards? 29. Likewise, the 13th person also he will post 29. So totally how many 29s? 30 times 29. Or else, as per this railway question, each 2 person is connected. We can write 30 P2. Okay. That should reach all the persons. So any 2 person is connected. Selecting 2 at random. So this is 30 factorial by 28 factorial. If you simplify, you will get this one. So 30 into 29. How much? 3 2s are 6, 27, 870. Okay. Totally 870 postcards has been posted. Then 18p r minus 1 is to 17p r minus 1 equal to 9:7. Then find r. We'll come back to that question also later. See, 7th question. Find the number of ways of arranging, underline that word arranging, 5 boys and 4 girls in a line so that there will be a boy in the beginning and in the ending. So that there will be a boy in the beginning and in the ending. Totally how many people we are arranging? 9 persons. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So here one boy, there one boy can be arranged. How we can choose these 2 boys? Who goes first, who goes last? Totally how many boys are there? 5 boys. From 5 boys we should choose any 2. Then it is 5p2. Perfect, man. Then the remaining how many places? 9 places, 2 places we filled. Remaining 7 places. This 7 places has any restriction? No. This place has how many chance of filling? 7 people available for this. From this 7, any one we can choose. So we choose the one. Then for this box, 6. For this box, 5. For this box, 4, 3, 2, 1. So 7 into 6 into 5 into 4 into 3 into 2 into 1, that is 7 factorial. Okay. Any doubts in this? No. Can you able to solve this? Okay. Try solving this. Then we'll move on to next question. We'll move on to next question. See the question number 8. Find the number of ways of arranging 6 different mathematics books, 3 different mathematics books and 2 different chemistry books such that the books of the same subject are together. Okay, we have 6 different mathematics book and 3 physics book, 3 different physics book and 2 different chemistry book. This should be arranged, man. So we'll make that shelf as 3. Look at here, man. What you are searching? See, either we can give this rack to maths, this rack to physics, that rack to chemistry, or else CMP. Likewise, how many ways this can be arranged? This box has 3 options. This box has from the 3 groups, we allotted 1 group here. Then this box has how many chances? 2. Then this box has, okay. So these 3 groups can be arranged in 3 factorial ways. Also, after arranging the books here, they say they are different books. So the first box can be splitted as 6. First box is 6. Second box is 3. This one 2. So inside this, how many ways of arrangement possible? 6 books. So 6 factorial. And inside this, how many ways of arrangement possible? There are 3 books. So how many ways? 3 factorial. Now inside this, how many ways of arrangement possible? 2. So 2 factorial. Okay. Arranging the groups. All together, we consider this whole 6 books as 1. This one as 1. That one as 1. So totally 3. The 3 can be arranged in 3 factorial ways. After arranging MPC or CMP, whatever, in that arrangement, the 6 books can be arranged in 6 factorial ways. Inside that. And inside that, these 3 books can be arranged in 3 factorial ways. And these 2 books can be arranged in 2 factorial ways. Okay. Clear? Any doubts in this? Okay. The remaining questions, there are 3 questions are there. Those 3 questions we'll see in tomorrow's class. How was your, what is your thought on this permutation? Was it easy or tough? Or seems to be tough? Easy. But what we have to do is, you should think deeply. You should think all the possibilities. Okay. Train your mind to think the same way. We have another package of questions also there. Try those questions on your own. Ask me if you have any doubts. We'll discuss. Okay. This prove that, show that question and I'll leave it. That I'll solve in next session. Okay. Okay. Then any doubts in this?